Welcome to section 13.4, General Approach to Factoring. So what I mean by general approach to factoring is talking about incorporating all the techniques that we cover for factoring, such as GCF, grouping, and then the technique that we did for factoring with trinomials, and then recently the method that we did for factoring perfect squares and difference square. So by general approach, it means that a combination of these techniques that you would use all together when factoring a problem. So, meaning that you should be familiar with all techniques that was covered within this section. And if you were to incorporate multiple techniques, what you usually check first is if you can factor by GCF, and then grouping, and then factoring these three last. So, what I mean by these three last is depending on what type of problem that you have after you factor by GCF and grouping, you check if it is a typical trinomial, then you just use the method for factoring trinomials. Or if you have a perfect square or difference square, then you use the methods covered in these two sections. So let me review. When you come into a higher level of a quadratic or equation that you have to factor, so a quadratic or a higher level to the third degree or fourth degree, or multiple variables, for a general approach, check if you can do GCF and grouping, and then once you finish with those two methods, then these three right here, depending on what kind of problem you have, is either a trinomial, perfect square or difference square, or a combination of one of these three altogether. So you don't know what you have until you finish factoring GCF or grouping. Once you have done that, you can identify based on the technique that was covered in these three sections. So in our first example, we have 6x squared plus 9x minus 60. So I'm going to check if there's a greatest common factor in each of the terms. So they don't have the same variable. So let's take a look at the numbers, 6, 9, and 60. Well, based on these three numbers, we can factor them by a common factor of 3. So I'm going to divide each term by 3. So my GCF, the 3, will be outside the parenthesis. So 6x squared divided by 3 is 2x squared. Then 9x divided by 3 is 3x. And then the negative 60 divided by 3 will be negative 20. And then close parenthesis. So I finished factoring by GCF. Now in here, inside the parenthesis, is a trinomial. So based on this one, I know that this is not a perfect square because the first term and the last term are not perfect square. So and this also fit for difference square. So this would be a trinomial. So I'm going to just factor using the method for factoring trinomials. So here I underline this is my A, B, C. So A is 2, B is 3, and then C is negative 20. So factoring the trinomial where A is not 1. So remember, the top is A times C. So C, A times C. 2 times negative 20 is negative 40. And then my B value goes at the bottom. So it's going to ask you what two numbers can multiply into negative 40, but the sum and difference is 3. So you have to think about numbers, what you can do. So I'm going to list it out over here. So you could do negative 20 times 2, which is negative 40. But the sum and difference between negative 20 and positive 2 is negative 18. So that won't work. So what you could do is say negative 8 times 5. That will give you negative 40. The sum and difference between negative 8 and 5 is negative 3. That's almost the same as my B value. So instead of negative 8 and positive 5, say I do negative 5 times positive 8. That would give me negative 40. The sum and difference between negative 5 and 8 is a positive 3. So this will be negative 5 and positive 8. And let me write over here. Negative 5 and positive 8. Now since my a value is not positive 1, let me incorporate the variable x here and x here. So what I'm going to do is set up for factoring by grouping. So the first one, 2x squared, and say I use negative 5x, and then plus 8x, and then the last term minus 20. Alright, so we're going to factor by grouping. So the first half, I'm going to divide by a common factor of x. So x will be on the outside. 2x squared divided by x is just 2x. And then negative 5x divided by x will be minus 5. Close parenthesis. Alright. Next is the other side. So what's in common between 8x and minus 20 is the 4. So my GCF will be outside, so plus 4, parenthesis, 8x divided by 4, 2x, negative 20 divided by 4 will be minus 5, close parenthesis. So these two are exactly the same number, same sign. So I'm going to group these two together. So x plus 4, and parenthesis, and then 2x minus 5. So now I'm going to bring it back over here. So in place of 2x squared plus 3x minus 20, I'm going to put in x plus 4 times 2x minus 5. But remember, I also did factor by GCF, which is that 3. So it didn't really disappear. It's still outside, so we'll bring it down here. So my full answer is 3 times x plus 4 times 2x minus 5. So that is my full answer in factor form. And let me box that up. So here is our full answer, the 3, the x plus 4, and 2x minus 5.